Hi, and welcome to the Build Your Own Data Logger course, brought to you by FreakLabs and WILDLABS. I'm Jacinta from FreakLabs. This is Module 8, In the Field. We've assembled the hardware, coded our application, and tested our device. Now it's time to deploy. This is the final module of the course, and we'll be looking at field equipment and troubleshooting in the field. We'll go through some tips, look at different kinds of field equipment, and go through some general troubleshooting pointers. In Module 7, we looked at lab, sandbox, and pilot testing our devices, and by now we should have flushed out the common and some not so common bugs. Yet despite this testing, we still assume a 10% hardware failure rate in the field. So pending luggage restrictions, we'll take enough spare boards, enclosures, cables, and peripherals to cover ourselves. We also take our laptop into the field. However, we generally only do basic debugging, checks, and maintenance. If we can't fix the issue on the spot easily, and we have enough spares, we'll just swap the device or damaged part out, and then debug it more thoroughly and fix it back at base or in the lab. Throughout the deployment, we'll also mark any damaged equipment with a red dot sticker and keep a failure log of which device it was, what failed, when, why, etc. The failure log is good because over time, we get a good picture of the lifespan of the device in general and the durability of the parts and enclosures we've selected. For example, if we find a particular temperature sensor fails quite a lot, we can try another one from a different manufacturer. Or if our enclosure wears and weakens too soon, we can look at a different enclosure and mechanical design altogether. So there's 3 categories of equipment that we'll look at: general tools, tools to repair the devices, and electronic development tools. Let's start with the general tools. To reduce carrying lots of luggage, we try to only take tools that serve more than one purpose as much as possible, although this can't always be the case. In the field, it's more important to have a decent tool than no tool at all. The utility knife is used all the time. We're constantly cutting tape, cutting off cable ties, etc. The Swiss Army knife doesn't get used that often, but comes in handy if we're heading out and need a general purpose tool to toss in our pockets. The wrench multi-tool is useful for tightening nuts on mounts. The micro screwdriver is good for opening things with small screws like laptops or electronic devices. The long-necked screwdriver is one of those single-purpose tools, but it's a lifesaver. It's useful for screws that have a long, narrow access hole, whilst the modular screwdriver is great for any other screwdriver needs like hex screws, pentalobes, various size Phillips screws, etc. Wire cutters are good for many things like stripping wires, cutting plastic, and cutting fingernails. Scissors, post-its, dot stickers, and pens are good for labelling things like damaged or repaired equipment. Plus, we'll take any site-specific or project tools we might need. Now let's look at essential electronic repair tools. We'll take a soldering iron with an adjustable temperature control and a multimeter. We'll also have a desoldering pump. The desoldering pump is used to desolder connectors and other through-hole components. There really isn't any other good way to remove these. We also carry soldering equipment in general, such as an extra soldering iron tip, sponge, and flux core solder. Extra screws and nuts come in handy when they accidentally drop or get lost. When you're in the field, small things like that can be a pain to find locally. Then there are the crimpers and wire strippers to crimp cable harnesses, and of course the cable harness housings and terminals in various configurations. In addition to spare boards, parts and peripherals, we'll also take some electronics development tools in case we need to do some light development work or repair work back at base or the lab. However, we'd say some of this equipment is optional, depending on how long you're going to be in the field and how comfortable you are with the electronics. We bring one of the Arduino development boards we designed for field prototyping. We also bring a USB to 2.1mm power jack cable, which can be used to power this board and other boards. There is the Arduino bootloader programmer in case we have a bootloader fail on a board. A USB serial bridge comes in extremely handy for development also. Then there are various prototyping jumper wires, PCB jumper wires, power wires, and signal cables we can use to make a cable harness. A general purpose memory card reader is very useful, since we often use SD cards in our devices. The cable twist ties are just to organise cables. Extra USB cables and mobile USB batteries to power devices in the field are super useful also. Finally, we'll have a selection of cables and power, USB and other adapters that we'll need, based on what we know of the setup at base or in a lab that's not ours. Of course, we need to put equipment in something, so we use carry cases like this one. It's good because it's got handles and is fairly lightweight, so it can be tossed in the back of a truck, although you have to be a little careful it doesn't crack. There are sturdier ones you can get. This one can also fit in a suitcase or a backpack, and it has separators to organise various parts like wires, connectors, etc. Plus it's also relatively inexpensive. So once we're in the field checking on the devices, we usually carry a laptop, and we'll go through in a bit how we debug in the field. However, if you can't carry a laptop, we recommend simply swapping out anything that looks damaged and not taking any chances. So the first thing we'll do is a visual inspection of the mechanicals. For example, is the enclosure breached? Is the gasket in properly? We'll also do the same for any peripherals. Has anything been chewed or broken? Then we'll check the cables and connectors are secure and haven't been knocked out or torn or damaged. We'll check the batteries are securely inserted and aren't flat, and the SD card is still inserted properly and isn't full. And we'll also check there's no loose components on the actual circuit board itself. If we have a multimeter with us, we'll check the battery voltage and the power supply voltage. We'll also do a visual inspection for any corrosion on the board or peripherals. If we find any of these, we'll swap it out or fix it if we can. Then we'll reset the board and test the system is working okay. It's important to test even after just swapping out a part because the initial mechanical damage could have damaged the electronics as well. If we can't find any mechanical damage or we've fixed and replaced a part, we test the system via our laptop. First, we'll switch the LED lights on so we know the board is alive. Then we'll check the SD logs to find out how long it's been down and whether there were any erratic or unusual readings before it went down. If there was, it might suggest a loose component on the board or a loose cable connection. Then we'll download the test code and use the command line to test each functional component individually and then test the complete system. If the system is working okay via the command line, we'll download our modified accelerated testing code and hammer the system for as long as we can. Once we're satisfied the device is working again, we'll download the deployment code, switch the LEDs off and do a final battery and SD card check before closing up the enclosure. Then we'll do a final check of the cables and mechanicals before heading off to a restful night's sleep, secure in the knowledge that our device is up and running again. If we don't have our laptop, we do the visual inspection and swap out anything that looks damaged. Then we'll switch the LEDs on to check it's powered and reset the board. If we can, we'll test the board manually if there's a test button on it. However, if the device is down and there's nothing obviously wrong with it, we generally just swap it out with a known working system, so we can take it back and debug it with our laptop at base. These tips are quite general, mainly because the specific debugging process depends on the system and what you have access to and how long you're going to be there. But hopefully there's some useful information there. And that, my friends, is the end of Module 8. Congratulations! You've completed the Build Your Own Data Logger course. We hope you're sitting with your feet up, your beverage of choice, and casually checking the data streaming in from your custom data logger. Thanks for taking the plunge with us, and we can't wait to see what devices you'll build next.